Okay, so the next two questions are both, again, quite similar. They're both this time to do with exponentials and logs and stuff like that. Okay, so let's have a look at question 10, and I'll do the same as last time. I taught you through question 11, ask you to have a go with it, and then I'll do it. So the curve C has this equation. Find the equation of the normal to C at the point where the curve intersects the y-axis. Give your answer in that format. Okay, so a couple of little things there. Obviously the normal, that means we're going to be using minus 1 over m. And intercepts the y-axis, that means where x equals 0, doesn't it? Okay, and there is a problem that we're going to encounter with that in a second because of the fact that we've got an e in this. Okay, so firstly, normals, anything to do with that, we know we've got to do dy by dx, haven't we? So dy by dx here will equal 2e to the x, we'll just times by the coefficient of x there, don't we? And then keep everything else the same, which means that's going to stay as 2e to the x, times by the power, decrease the power by 1, we're going to get that, and the 2 will disappear. Okay, so to figure out the gradient at the point where the curve intercepts the x-axis, we're going to have to sub in x equals 0. So your gradient will equal 2e to the 0 plus 6 times 0. 6 times 0 was nothing, but 2e to the 0 will give us 2, because remember e to the 0 is 1, so that's going to give me 2. Which means that my gradient for the normal is going to be minus 1 over 2. Okay? So I've got a gradient, I need a coordinate. I know the x value of the coordinates would be 0, but we have a problem here with the y-coordinate. Now usually when we've got a curve, we'd say, well, if we're looking for the y-intercept, it's 2, isn't it? But there is a problem with this, it isn't 2 on this one, because normally when we sub x equals 0 into a equation, it just means that everything with an x in disappears. That isn't true when it's e to the x. When x equals 0, y will equal 2e to the 0 plus 3 times 0 squared plus 2. Now that will equal 2 plus 0 plus 2, so it will actually be 4. So the y-intercept for this curve is actually 0, 4. So we can now use this and this in y minus y1 equals mx minus x1. So y minus 4 will equal m x minus 0. And rearranging that, we're going to end up with y, I'm going to leave it on there actually, y minus 4 equals minus a half x. I want everything on the same side, don't I, because of this thing up here, ax plus by plus c. So I'm going to take over to there, I'm going to double everything, and then take that over to there. So that's going to go to a positive x over here, plus 2y minus 8 equals 0. So that's my answer there. Okay. So that one, there isn't a particularly tricky part of that, I think. It's just this. It's missing that, okay? And thinking, well, the y coordinate there, the y-intercept, sorry, is going to be 2, so just be careful with those kind of graphs, okay? So question 11 is similar to that one in the sense that you're going to be differentiating with logs and stuff. So remember that when you differentiate log x, you will get 1 over x. But remember that when you differentiate 1 over x, remember to turn that into x to the minus 1 before you differentiate it. Okay? So what you're going to do for this one, the point P is a stationary point on C. Remember that means that when you get dy by dx, set it equal to 0. And then as soon as you solve that, that's your answer, because you're only being asked for the x coordinates of P there. And then the point Q on C has the x coordinate of 1. Actually, sorry, it's not f, it's f dash of x actually there, sorry, isn't it? Not dy by dx. The differential is called f dash of x because you've got f of x. As x coordinate 1. So if you sub that into your gradient function, it will give you the gradient at that point. Again, you're after the normal, aren't you? So you're going to then do minus 1 over that number. You will then need to sub x equals 1 into this to get your value for y. And then you've got your coordinates and your gradient, and you can use y minus y1 equals mx minus x1 to finish that off. Okay, so pause the video please, have a go at question 11 on your own, and then I'll talk through it when you come back when you're ready. So what you should have noticed, what you should have done anyway, was that f dash of x was 3 times 1 over x, which is just 3 over x, plus, and then when you differentiate this of x to the minus 1, you're going to get minus x to the minus 2, which means that's going to look like this. Okay? And remember, we want to set that equal to 0 because it's a stationary point, and then solve it. So we're going to bring the 1 over x squared over to this side, so we get 1 over x squared equals 3 over x. And then the way that I would solve that is I'd put the 3 down there, the x squared up there, so I'm going to get 1 over 3 equals x squared divided by x, which means that x will equal a third. Okay, so that's part A done. Part B, find an equation for the normal at Q when x is 1. Okay, so I'm going to do f dash of 1, that means sub 1 into this thing. That will equal 3 over 1 minus 1 over 1 squared. So we've got 3, take away 1, which means it's 2. Because it's the normal, I'm not going to use that. That's effectively the gradient of the tangent at that point. I want the gradient of the normal, so that will be minus 1 over 2. And then, remember, I need a full coordinate to be able to figure out the equation of a line. Now I've got my gradients. I've also got an x value, so I need the y value. So I'm going to do f of 1, 3 log of 1 plus 1 over 1, log of 1, sorry, not 1 of x. Log 1 is 0, so f of 1 is just going to give me 1, which means that my coordinates is 1, 1. Okay, so I can now do the equation of the normal by going y minus 1 equals m, which is minus 1 over 2, brackets x minus 1. So I get y minus 1 equals minus a half x plus a half, and minus a half times 1. Get all that over to the side. Y equals minus a half x plus a half plus 1 will be 3 over 2, 1 1/2. Okay. So well done if you got that right.